Hello everyone, I'm Frank, and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt, because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Imperfect Reflections by Jake Styles Owen. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9, such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have mirrors, where cells equidistant from a white mirror are consecutive. Oh. Cells equidistant from a black mirror are in a 1:2 ratio. And cells equidistant from a red mirror are the same parity. So this is kind of like, in a sense, Ziffer lines. No, not really, but it kind of is. But it's basically mirrors. Note, mirrors do not interact and thus can see through each other. So the black mirror, for example, sees exactly 3 pairs of digits. Row 3, column 3, and row 3, column 4. Row 3, column 2, row 3, column 5, and row 3, column 1, and row 3, column 6. Right. So, as an example, for the white mirrors, these 2 digits must be consecutive, and these 2 digits must be consecutive, because they are the cells that are equidistant from the white mirror, right? So they have to be consecutive. These 2 digits are in a 1:2 ratio, and these 2 digits are in a 1:2 ratio, as are these 2 digits, because those are the only digits which are or cells which are equidistant from the mirror, right? This doesn't have an equivalent here. This doesn't have an equivalent either. And for parity, these two are different the same parity. Okay, so red mirrors are same parity. So these two are the same parity, these two are the same parity, and these two are the same parity. Excuse me. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so the one that stands out the most to me, well, there's a couple, but it's really this one that stands out the most to me, because these have to be the only digits which are in a 1:2 ratio are 1, 2, 4, 8, and 3, 6. Now, 2 and 4 could be with each other, but if all 6 of them have to be used, it's 1 and 2 are together, 4 and 8 are together. So this has to be a 1, 2, 3, 4, 6, 8 sextuplet, which means the remaining digits are 5, 7, and 9 here. Now, these are all odd. So, and we have parity mirrors, which mirror these two cells, which mirrors basically rows 5 and 6, rows 5, 6, rows 4, 7, rows 8 and 9. That's not right. Rows 5 and 6, rows 4 and 7, rows 3 and 8, and rows 2 and 9, because those are the equidistant possibilities for those cells. Well, you can only have 2 of each pairing, because if you have 3 of a pairing, that means 6 of the cells would be either all even or all odd, and that's not allowed. You have to have 4 and 4 of each, which means in row 1 of those columns, you have to have odd digits. So these are odd, which means the remaining digits in that box are even, because we have already 3 odds here. So this is 1 and 3, this is 1 and 3. To mirror this must be odd, this must be even, and this must be odd. So these are even, which forces both of these two to be even, and these two have to be odd to match these odds. So this is odd and odd. This is even and even. These digits have to... Oh, we have consecutiveness here. So next to 5, 7, and 9, 9 has to be guaranteed next to 8. 7 then can only be next to 6 or 8, but 8 is taken, so it has to be next to 6. And 5 has to be next to 4 or 6, but 6 is taken now, so it has to be next to it has to be next to 4. So opposite of these three across the mirror have to be 4, 6, and 8. So this is 4, 6, and 8. Of those, the only two that can be in a 1 to 2 ratio are 4 and 8. So therefore, this is 6. 6 has to be in a 1 to 2 ratio with 3. So that 3 is only consecutive with 2 out of 1 or 2. So this is 2, this is 1. 6 has to be consecutive again with 7. So this is 7. And then 9 has to be consecutive with 8. 5 is consecutive with 4. 6 is consecutive with 5 or 7 here. So we know, okay, we're marking evens and odds because of the parity mirrors. So, and also that actually kind of works with the white crop key mirrors, I guess. So this is odd. These are even. These are odd. So, sorry, this is odd. This is even. Therefore, this must be even here. It's consecutive. It has to be 4. That eliminates 4 here. So this is 8 and 4 here. 8 has to be consecutive with 9. So this is 9. That's 5. 8 and this digit are consecutive. So this is odd. This is odd. This is even, even. So this must be odd, odd. This is odd, odd. So this must be even, even. And that's it for that. This is odd and even. So the thing is, these two are consecutive. Since this is odd, this must be even. We have four evens in box 2, so this must be odd now. We are guaranteed. Okay, that's not helpful. So these are matching sets here of parity. You cannot have 3 sets of odd digits, so one of these pairs must be even. If one of these pairs is even, though, we know that there's 2 more evens in row 9, so the rest of the digits must be odd. So this has to be odd here. That's consecutive with this digit, which makes that even. This has to be a 6 because it has the last even digit. These parities are the same, so that's red. These parities are the same, so this is blue. We have 4 odd digits here. Oh, we have 4 even digits in row 2, so this cannot be even. These are all odd. Since this is odd, this must be odd here to match parity. So that leaves, okay, yeah. We have the same reasoning that we have in columns 1 and 3 as we did in columns 7 and 9. To form full pairs, you have to have essentially 4 odd digits and 4 even digits for the parity because they must match. So this must be an odd digit, which makes, and this must be an odd digit. That makes this an odd digit here and an odd digit here. We have 5 odd digits in row 9, so this must be even. This must be even. Even is consecutive with an odd digit here. Odd is consecutive with the even digit here. Remaining digits in column 1 specifically have to be even because we have 5 odd digits. So this is even. This is a red odd even pair, but that doesn't tell us very much. We don't know about these. Okay. This is odd. So this must match with an odd here. One of these pairs is even, one of these pairs is odd. We don't know which. We have 4 odds in... Okay, yeah, we have 4 odds in box 7. So this cannot be 2 odd digits. One of these is guaranteed to be even. So this is even. We have 1 guaranteed even here. And this is even. And one of these must be even to be consecutive. So that means the rest of the... So this has to be specifically 1 even. So this is 1 even, 1 odd. That forces this to be even then. Even has same parity with even here. So this is even. That forces this to be odd, which forces this to be even to be consecutive with it. So again, this is an odd even pair. This then must be 2 odds here. And we have 4 evens in box 4, so this has to be 2 odds. This is odd, therefore that must be even to be consecutive. This is odd, so this must be even to be consecutive. These are the same parity, so this is even, even. These are the same parity, so this is even, even. This is consecutive with the rest of the digits in row 7 are odd because we have 4 even digits. Therefore, this is even. These evens are consecutive with odd digits, so those are both odd. We have 5 odd digits in box 8, so this can't be odd. This is even. That leaves this as an odd digit, and that works because these are consecutive. So then we see what matches. This is blue, so this must be blue here. This is red, which means this is red here. We need 2 more blues in column 9 and 2 more reds in column 7. So this is red and blue. We have 4 blues in box 6. That leaves the remaining digits as red. We have 4 blues in row 4, so that means that's red. We have 5 reds in column 6, so this is blue. We have 4 blues in column 5, so that means this is red. We have 5 reds in row 5, so this is blue, which makes this red here, because we have 4 blues in box 5. So now we just have to fill them out by normal Sudoku, knowing that these are essentially odds and evens. We do have consecutive too, actually. So we should do that also. This is a 2-8 pair here. Therefore, this must be 4 here. That makes this 2, 6, and 8. Parity doesn't really help, so we should probably focus on the consecutiveness. 6 is consecutive with 5 or 7. 8 is consecutive with 7 or 9. This is a 2-8 pair. Okay. 2 has to be consecutive with 1. So that means one of these is 1, because it cannot be consecutive with 3. But 8 can be consecutive with 7 or 9, so this is 7 or 9, so that's not helpful. If this is 2, this is 1, and this would be 3. If this is 8, this is a 7-9 pair to be consecutive with, right? What else do we have? These digits are consecutive, but we don't have any restrictions, really. What about these? So these have to be 2, 6, or 8. But these could be then 1, 3, 5, 7, or 9. No 5. But that's not helpful. These are consecutive. Okay. Remaining digits in row 1 are 5, 7, and 9. Okay. We have a 5, 7, 9 triplet actually in box 2, which eliminates 5, 7, 9 in the rest of the box. So this has to be 1. So this is 1. One of these is 5, so this cannot be 5 here. 7 and 9 can only be consecutive with 8. So this has to be 8 here. 7 9's consecutive with 8. 5 7 9's consecutive with 4 or 6. 2 cannot be here. Where is 2 in box 5? It has to be here. So this is 2. This cannot be 4 or 8, so this is 2 or 6. This is 4, 6, or 8 here. This is 4 and 6. This is 4 and 6 as possibilities. This is 2, 4, 6, 8. That's fine. This digit can never be 7, but that doesn't help us much. These are consecutive with these. That's not helpful. These consecutive is done. The 1 to 2 ratio is done. Parity doesn't really help us now anymore. This consecutive is essentially done. So is this. So is this. 2 is consecutive with 3. 8 is consecutive with 9. 4 is consecutive with 5. 6 is consecutive with 7. 4 and 8 are in 1 to 2 ratio. 3 and 6 are in 1 to 2 ratio. 1 and 2 are in 1 to 2 ratio. This is essentially done. This has to be 3, 5, 7, 9. That's not helpful. One of these is a 1, so this cannot be 1 here. So we have 5, 7, or 9 here. This force, okay, so this digit, so this is a 2-4 pair here. This digit cannot be either of these digits, so it must be the same as that digit. And the only way they're the same is if this is 4 and this is 4. So then this is 2 here. This is 4, so this cannot be 4. That's 6, which means none of these are 6. Where's the 4 left in row 7? Can't be here because of 4's in the boxes. So it has to be, it can't be here because 4 in the column. So this is 4. 6 is consecutive with only 5 or 7. So that's 5 or 7. This can't be 6 anymore. This is a 4-8 pair, which eliminates 4 and 8 in the rest of the box. This can't be 4. That's 6. So this must be 2 or 4 in the rest of row 4. This can't be 4 because of 4 in the column. So this is 2. This is 4. 2 cannot be here. So this must be 6. That makes this 2. Can't be 2 here. This is 8. That's 2. We have 2, 4, 6 already in column 1. So this is 8. This is 6. 6 is consecutive with 5 or 7, as I said. Where is 3 in row 8? It cannot be here. This because of 3 in the column. This because it's not consecutive with 6. So 3 has to be one of these 3, which means this cannot be 3. Okay, 2 eliminates 2 here. This is 6 or 8. This is 6 or 8. And this must be 2, 6, or 8. 2 cannot be here. This is 4, 6, and 8. This can't be 6 because of the 6 in the row. Okay. This is 6 or 8. It's only consecutive with 7 or 9. So this cannot be 1. One cannot be here. Where's 1 in box 5? It has to be one of these two. One in box 8 is one of those two. So 1 cannot be here. 1 is one of those 3. 1 is one of those 3. So, yeah. We have 1 and 3 here, but we don't know where. Oh, these digits are consecutive. So 6 is consecutive with only 5 or 7. So that's 5 or 7. 4 is consecutive with 3 or 5. And then 2 and 8 can be consecutive with 1, 3, 7, or 9. And this can't be 1 because of 1 in the column. So we have a 3, 5, 7, 9 quadruplet, which eliminates 3, 5, 7, 9 in the rest of the row. This can't be 3, 5, 7, 9. It's a 1, which eliminates 1 in the rest of the box. Where is the 1 in row 8 then? Can't be any of these cells. This can't be because of the 1 in the box. This can't be because it's not consecutive with 6. So this must be 1 here, which is consecutive with 2. So this is 8, which means this cannot be 1 here. Where's the 1 in box 5? It has to be here. So it's 1 here, which means this can't be 1. 2 is consecutive only with 3, so this is 3, which eliminates 3 here. So this is 5, this is 7, that's 9. So 2 is consecutive, this makes that an 8, which makes that a 6. This can't be 6 anymore. This can't be 6 or 8, so it's 2. So that's no 2 there. We have a 4, 8 pair in column 9, which eliminates 4 and 8 in the rest of the column. This can't be 8. This is 6, which makes this 8, which makes this 6. And this 4, 8 pair eliminates 8 here, and the 6 eliminates 6 here, so this is 2. 8 is only consecutive with 7 or 9. And we have 6 with 7 or 9 here, because this cannot be 3, and it can't be 5. 6 is only consecutive with 7 out of 7 or 9, so this is 7, that's 9, which leaves a 1, 3 pair remaining in column 8. This leaves a 3, 5 pair remaining in column in row 8, which eliminates 3 and 5 in the rest of the row. This can't be 5, this is 7, this can't be 7. Okay, so then this 5 eliminates 5 here, so it's 7, which makes this 9. 7 eliminates 7 here, so that's 9, which means this can't be 9, and this can't be 9. 7 eliminates 7 here, so it's 5 and 7. That leaves this digit as a 3, because we have a 5, 7, 9 triplet in box 5. 3 eliminates 3 here, so it's 1 and 3. This can no longer be 3, so this is 5 or 9. This 5 eliminates 5 here, so it's 9, which makes this 5. 9's only consecutive with 8, so this is 8, and that's 4. 8 eliminates 8 here, so it's 4 and 8. 1 eliminates 1 here, so it's 3 and 1. 3 eliminates 3 here. That's 3 in the corner. We celebrate because we're close to solving this. That's 5 and 3. That leaves this digit as a 9. And I think we've done all the consecutive ones now. Let's just check. Okay, so all the parity should be fine. Same parity, same parity, same parity. Same parity, same parity, same parity, same parity, same parity. Yep, those are all the same parity. These two, these two, these two, these two. These two, these two, these two, these two. These are all even. That's odd, odd. Odd, odd, even, even, odd, odd. So those are parities are all done. 1 is in the 1 to 2 ratio with 2. 6 and 3 are the 1 to 2 ratio, so is 4 and 8. Consecutive, 9 is consecutive with 8. 7 is consecutive with 6. 7 is consecutive with 6. 9 is consecutive with 8. 6 is with 5 or 7. 4 is with 3. 3 and 2 are consecutive. 8 and 9, so are 4 and 5, so are 6 and 7. 2, 3 are consecutive, 6, 7 are consecutive, 5, 4 is consecutive, 9, 8 is consecutive. 2, 1 and 8 with 7 or 9 are consecutive. 6, 7, 8 and 9 are consecutive. 8, 9, and 6, 7 are consecutive. So yeah, we just have to do normal Sudoku. Remaining digits in column 2 are 1 and 3. This can't be 1 because of 1 in the row. So this is 3, this is 1. We have 1 and 3 remaining in row 9, too. This can't be 1 because of 1 in the column, so this is 3, this is 1. Where is the 3 in... We have 3 and 5 remaining in row 2. This can't be 3 because 3 in the column, so this is 5. That's 3. That leaves 5 and 9 remaining in column 3. This can't be 9 because of 9 in the row, so this is 5. That's 9. 5 eliminates 5 here, so it's 7, which makes this 9, which makes that 5. That leaves this digit as 7, this digit as 5, and this digit as 7. And that's how you solve it. Pretty interesting, actually. I've never run into these mirror things before, but it's very interesting. It's kind of like crop key dots, but extended crop key dots. So that's one interesting aspect of it. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.